Alright, so today's lesson is completing the square, meaning we are going to take a quadratic in standard form, for example this one, and we're going to put it into factored form down here. Okay, so not factored form, vertex form. So we've done vertex form before, but we've never actually changed from standard into vertex. So here's the steps. We're going to go through this example, and then we're going to do another example together. So if we have this problem, which is 2x squared plus 12x minus 5, we want to change this into vertex form. Here are the steps we're going to do. First, you're going to look at those first two terms, these two here, and see if there's a common factor. Just the coefficient. Obviously x is a common factor, but we're just going to see if there's a common factor among the coefficients. In this case, there is. 2 works. Right, so we're going to pull out a 2. So when we pull out a 2, then we have brackets x squared plus 6x. Now what we need to do is we need to turn this into a perfect square. So to do that, we take that middle term, right, in this case 6, we divide by 2, always by 2, okay, and then whatever we get, we square it. So we end up with 9. And so what we do is we add 9. You can't just add 9 to the equation though, because then that changes it. So to make sure you don't actually change the equation, you're also going to subtract 9. Adding 9 and subtracting 9 is like adding 0. You're not changing the equation. But what that does is it makes these first 3 terms here a perfect square. So now that they are a perfect square, we can rewrite them as x plus 3 all squared. But we're still left with this minus 9 here, so we're just going to keep that there for now. And the next step is to take this 2 and distribute it. So it's going to be multiplied by that inner bracket and by negative 9. So we get 2 times this x plus 3 squared minus 2 times 9, which turns out to be negative 18. Now throughout everything we've had this negative 5, and we've just left it alone. We haven't done anything with it. But now we have 2 like terms here. So we're going to add them together. So negative 18 minus 5 gives us minus 23. And now you're left with vertex form. Okay, so let me just pause there to see if anyone has any questions. Alright, now that we have that, let's go on and try an example on our own. So in this example, you can think of it if you're like worried that there's no term, that there's no like a constant at the end. You can add a 0. Right? And now that looks like your standard form for a quadratic. So first step is we're going to look at these first 2 terms. And we're going to pull out a common factor if there is one. Now in this case there isn't one. And if there isn't one, that's fine. Then we just can ignore that first step. So the second step will be to take that middle term here, divide by 2. So let's just do this on the side. So 4 divided by 2, that's 2. And then we're going to square that. Right? So 2 squared is going to give us 4. So once we have that, we can add and subtract 4. So we will have y equals x squared plus 4x. And I'm going to add 4. And then I'm going to subtract 4. I don't have to keep writing plus 0 though. Right? Once we've done that, this here is a perfect squared. It is x plus 2 all squared. And then you're just left with this negative 4 on the end, so minus 4. And that's it. You're done. That was a fairly easy one, but we'll try more difficult ones. But remember with vertex form, we can easily pick out the vertex. So our x-coordinate is right here, but with the opposite sign, so -2. And our y-coordinate is right here, -4. And the axis of symmetry is where your x-coordinate is for your vertex, so -2. So those you can pick out fairly quickly from vertex form. Alright, so let's try one that's a little bit more challenging. Here we have this one here. Alright, step 1. Look at these first two terms and pull out a common factor, the greatest common factor, just among the coefficients. So in this case, -2. So let's pull out -2, and that leaves us, I'm going to do a big square brackets, that leaves us with x squared plus 8x. And then we still have this plus 1 that we'll just leave on the end. Again, we're not going to need that till the very, very end of what we're doing here. Now, look at this term. Take half of that term. So let's do this at the side here. So 8 divided by 2, that's 4. Okay. Square that, so 4 squared, that's 16. So now what we're going to do is inside this bracket here, we're going to add 16 and then subtract 16. So we get -2. Here we have x squared plus 8x. Now add 16 and subtract 16. And we still have this 1 that we're just going to ignore for now. Now right here is a perfect squared. Or again, if you want, you can think of it in terms of two numbers that multiply to give you 16 and add to give you 8. So it's 4 and 4. Therefore, we can factor those three terms to give us x plus 4 squared. But this -16 is still there. And our 1 is still there. Now that's not quite factored form. So what we're going to do now is we're going to take this -2, we're going to multiply it in here, in front of those brackets, and multiply it in here by -16. When we do that, we get -2 times x plus 4 all squared, and then -2 times -16, a double negative, so we get positive 32. And then we still have this plus 1 on the end. So now take these two constants, add them together, and we end up with our vertex form of the equation, -2 x plus 4 squared plus 33. From that, we can pick out the vertex, so the x-coordinate is -4, which is the same as our axis of symmetry, and our y-coordinate is 33. Just pause there. Alright, so in this example, same thing. Let's look at our first two terms and pull out the greatest common coefficient, I guess. So y equals, in this case, 5. So we'll pull out a 5. And I'm left with x squared minus 12x. And then we still got this -4 on the end there. So now I need to look at this middle term. So 12. Just going to look at the 12. So 12 divided by 2 is 6. And then 6 squared is 36. You don't have to keep writing it on the side. But it's going to be 36. So what we'll do is we will add and subtract 36. Plus 36 minus 36. And we still have that -4. Then looking at this trinomial, we can say, okay, what two numbers multiply to give you 36 and add to give you -6? In this case, it is a negative number, but that's okay. So negative 6 plus negative 6 is minus 12, and negative 6 times negative 6 is a double negative. It gives us plus 36. So we can write that as x minus 6 squared, and then we still have this minus 36. And we still have that negative 4 there. Now we're going to distribute the 5 into our bracket. So first we have 5 times x minus 6 squared, and then 5 times negative 36, which is minus 180, and still have that 4. These are your like terms, so your two constants, and we're left with our vertex form of 5 times x minus 6 squared minus 184. And from that, we can pick out the x-coordinate of the vertex, which is the axis of symmetry, and the y-coordinate. All right.